All right, so 4.4 exponential and logarithmic equations. So basically 4.4 takes um, all of our methods that we learned out of chapter 4 and even previous sections in order to enable us to be able to solve these equations. All right. So the first method, oh, let me say this as well. Um, you're going to learn multiple ways of solving equations. So when you come across an equation in your homework, there may be different ways you can go about solving the same equation and finding the same answers. And what is the easiest route may be just how you are seeing the problem at the moment, but that doesn't mean that it's the only way to get that answer. So we're going to go through multiple ways of solving your equations, dealing with exponential and exponential situations and logarithmic situations. But once again, most of them will have multiple ways of solving that equation. All right. So the first one is using the same base to solve. So you're talking about a one-to-one relationship for your bases. So if you have b to the m power equal to b to the nth power, if in other words your bases are the same, you can drop the bases and just be left with your exponents to solve. All right, so we have b to the m power equal to b to the n power. We drop those b's and we're left with m to the n. I mean m equal n, excuse me. All right. Questions on that before we're going to use it? All right, so the first one we're looking at 2 to the 3x minus 8 equal to 16. And then going back to what I was saying about, using there are multiple ways of solving your equations. It's not like it's going to tell you solve using, same base or one-to-one base relationship. So all you will get is solve. And according to what you see, you can use the methods that we're talking about in this section. So we have 2 to the 3x minus 8 equal to 16. And we want access to this x here, and this whole thing right here is an exponent. So we don't really have access to the x. So we need to figure out a way to get it down bottom. And so one way is to recognize or look at the 16 to say, is there a way for me to rewrite 16 in terms of 2? Or is 16 a multiple of 2? And the answer is yes, because that is 2 to the 4th power. So we can rewrite our equation in that way. 2 to the 3x minus 8 equal 2 to the 4th. All right, and now since our bases are the same, we can drop them and just be left with our exponents. 3x minus 8 equal to 4. All right. So from there, you can go ahead and just solve the equation you would, a regular linear equation, by adding 8 to both sides, dividing by 3. And your solution is 4. All right, questions on that? Questions?
So your answer is the exponent of 4.
No, your answer is x equal to 4. So in other words, when I plug 4 back in here, 3 times 4 is 12. And then 12 minus 4 is 12 minus 8 is 4, so that'll give me 16.
Can I go with the assumption if I have 2 to the 4th power, that will always be my answer, final solution?
Nah, it depends on what's going on in the problem.
All right.
Yep. Yeah, that was a coincidence. Yep, that was a coincidence. All right, let's look at another one. So down here we have 27x to, well, 27 to the x plus 3 power equal to 9 to the x minus 1 power. Now, what we have to do if we're trying to look at changing them to the same base, we need to either be able to change the 27 to a 9, change the 9 to a 27, or change them both to a power or to a multiple of that are the same. So we can change 27 to 3 cubed and 9 to 3 squared. So they both are multiples of 3. All right. So since they're both multiples of 3, we are good to go. Also, don't forget your exponent rules. The power to a power means that you will multiply your exponents. So here we have a power to a power in both cases. So that means we need to multiply them. And so I rewrote them right there. 3 to the 3 times x plus 3 equal to 3 to the 2 times x minus 1. All right. So now that our bases are the same, we simplify, we can just drop the bases. That'll give us 3 times x plus 3 equal to 2 times the quantity of x minus 1. Now we can solve our linear equation by distribution. So that'll give us 3x plus 9 equal to 2x minus 2. Now we want to get all of our terms with x to one side, all of our terms without x to the other. So we'll subtract 2x, then subtract 9, and x will be equal to negative 11. All right, questions? Any questions? All right, can we go to the next one? We're good. Our next method is we want to use logs in order to be able to solve. So it's re-emphasizing a couple of things that we talked about last section, in which, here in this first one, oh, my eraser was still on, sorry about that. Here in this first one, we have natural log of b to the x is equal to x times natural log of b. So that's just re-emphasizing the power rule. We can bring your x down front. That's one way that we can bring our x down bottom to be able to have access to it. Another way is that the natural log applied to e is going to cancel out and leave us with just x. And then the common log applied to 10 will do the same thing, cancel out and leave us with just x. So those are the things that we're going to emphasize in this these few problems. Want to make sure that we are okay with using logs in order to solve. All right. So first one under this type of thought process, we have 4 to the x equal to 15. So be careful here. This is not 4x equal to 15 where we would divide by 4 and solve for x. This is 4 to the x power. So we don't have access to that x just yet. But what we can do is apply the natural log to both sides. Now you could use log or natural log, it doesn't matter. In this case, because we have a 4 and a 15, neither one of them will cancel out into the log, to the natural log or the common log. So I just went ahead and used the natural log here. What this does though, it allows us to take x down front according to the power rule, and that will give us this expression right here, or equation, x times natural log of 4 equal to natural log of 15. Now to solve for x, I can divide by the natural log of 4 to both sides. Now be careful here, the natural log cannot cancel. In other words, what you cannot do is have natural log of 15 or natural log of 4 cancel out the natural logs, and that'll leave you with 15 over 4. So that cannot happen. The natural log is an application. So when you look at the natural log of 15, that's one number. And then the natural log of 4 is a number itself. So the natural log cannot be separated just by, canceling out in division. So that's the natural log of 15 over the natural log of 4. And if you want to approximate, my math lab will let you know what answer they want. And make sure you pay attention. If they want 3 decimal places, make sure, you give them the 3 decimal places and all the good stuff like that. Or if they want exact, then you would just write the answer, like that. Natural log of 15 over natural log of 4. All right. Questions? Any questions? Yeah, that's good. All right, next one. 10 to the x equal to 120,000. So here it would be in our best interest to use the common log since we have base 10 for that exponent. So we'll use the regular log and not the natural log. And so this log and that 10 will cancel, leaving us with just x. Then on the right side, we have a log of 120,000, which is approximately 5.08. All right, questions? Any questions before we do the next one? All right, so this next one, we have 40 e to the 0.6x minus 3 equal to 237. So this 0.6x is the exponent. Try to write it the best way I could, but that is an exponent. And then the minus 3 is just a regular minus 3. So what we want to do here is isolate the term that has x as an exponent. So we're talking about this e to the 0.6x. We want to isolate that. All right, so the first thing we'll do is add 3 to both sides. And that will give us 40 e to the 0.6x equal to 240. Then we'll divide both sides by 40. That'll give us e to the 0.6x equal to 6. All right, questions so far?
So you don't have to get x by itself?
Well, we're not finished. That's what I said, questions so far. But you do want to isolate that term that has x as an exponent. All right, so now because we have this e here, all right, we're going to apply the natural log to both sides. This is one of the times where the common log wouldn't be the best move, be the natural log, so that this natural log and e will cancel, leaving us with just the exponent of 0.6. 0.6x, excuse me. So it leaves us with just this. 0.6x is equal to a natural log of 6. All right. right, then we'll divide both sides by 0.6, and x is equal to 0.99 approximately. All right, any problems, any problems? All right. Next one, 5 to the x minus 2 equal to 4 to the 2x plus 3. Yes.
I just plugged that natural log of 6 divided by, oh, never mind. I know what I did wrong.
All right, not a problem. Not a problem, not a problem. All right, so here we have 5 to the x minus 2 equal to 4 to the 2x plus 3. And once again, we need access to those x's as long as they are exponents. We don't have full access to them. So, yep, my eraser's still on. So we're going to apply the natural log to both sides so we can bring them down front. That's what we did here. Natural log of 5 to the x minus 2. Natural log of 4 to the x, to the 2x plus 3. And applying the natural log to both sides allows us to bring the exponents down front. And that'll leave us with x minus 2 times natural log of 5, 2x plus 3 times natural log of 4. So make sure we're okay with the transaction. All right, so now we can go ahead and distribute the natural log of 5 into the parentheses, distribute the natural log of 4, and that will give us, let me do that and come bring it back. So that'll give us that x natural log of 5 minus 2 natural log of 5 equal to 2x natural log of 4 plus 3 natural log of 4. All right, so now notice we have x in two different terms. Your goal should be to get x on one side, all of your terms with x on one side, all of your terms without x to the other. So we're going to subtract 2x natural log of 4 from both sides and add 2 natural log of 5 to both sides. Once again, I'm trying to get all of my x terms to one side, all of my terms without x to the other. And this will be the result. X natural log of 5 minus 2x natural log of 4 equal to 2 natural log of 5 plus 3 natural log of 4. Any problems, any problems? All right, so now that we have x in two different terms on the same side, we're going to factor out x. So that's what I did down here. Pull x out of each term. All right. And from there, divide that quantity to both sides. Natural log of 5 minus 2, natural log of 4. Goal is always to get x by itself. And that's your answer. Approximately negative 6.34. Any questions? Any questions? All right. Can I scroll up? All right. Next one. We have e to the 2x minus 4e to the x plus 3 equal to 0. So remember from a previous section, it wasn't last section, the previous chapter, I think it was chapter 1, we came across quadratic scenarios wherein when we analyze our equation, if we had this term being squared in the first as our leading term, then we have a quadratic scenario, and that's what we have here. We have e to the x squared, and then e to x in our next term. So whenever we found that to be the case, we could let u be equal to that term. So we'll let u be equal to e to the x, just so that we could, so it could be easier for us to solve, just looking more familiar. That's the main reason why you would do something like this. All right. So we have u squared minus 4u plus 3. And we can solve this quadratically. And what I mean by that is that I'm going to factor, but if you don't want to factor, you want to use the quadratic formula, you can do that as well. It's up to you. Complete and square, whichever way you want to use to solve the quadratic equation that we have of u squared minus 4u plus 3 equal to 0. I decided to factor. That gives us u minus 3, u minus 1. Set both of those equal to 0 and solve. And we have u equal to 3, u equal to 1. So don't forget, we're not done because we started off with u with e to the x. So we need to substitute it back in. But just want to make sure we're good before we keep going. All right. So sub e to the x back in for u. And then solve by applying the natural log to both sides. So we see here using the natural log that cancels out the e, leaving us with just x on the left. Does the same thing here. Natural log of 3 is approximately 1.10. Then the natural log of 1, or the log of 1 period, will always be 0. All right, questions? Any questions?
The previous problem, Professor Tucker.
Mm-hmm.
I tried to plug it into the calculator. I didn't get, like, maybe I plugged it in wrong.
Did you use parentheses?
Yeah,
So you put,
I put two.
did you
Should I
do it
tell?
like that?
No, not like that. My calculator, when I put the log or the natural log button,
Mhm.
it brings the parentheses after it. So
Yeah, so you need parentheses around each numerator, the numerator and denominator.
okay,
Because what happened is that you divided when you don't use parentheses, that means you're dividing these two. You're
okay,
just dividing the middle pieces, but you're not dividing the whole quantities.
all right.
All right.
Mm-hmm.
Anybody else before we go to the next method? Everybody good? Okay. So remember when we first started dealing with logs and exponentials, we talked about how you can move from logarithmic form to exponential form or vice versa. So we're going to use that looking at these next few problems. Remember that log base b of x is equal to y. So that means that b to the y power is equal to x. So looking at here, we have log base 4 of x plus 3 equal to 2. And we can rewrite in exponential form. Remember, we start off with our base is 4. Whatever's next to the 4 in the log form should not be next to the form in the exponential form. So that's why we have 4 to the second power equal to x plus 3. All right, any problems? All right. So from there, you go ahead and solve your linear equation. 4 squared is 16, minus 3 from both sides, x is equal to 13. Any questions? All right, next one. 3 natural log of 2x equal to 16. All right, so first let's isolate that natural log. So we divide both sides by 3, giving us a natural log of 2x equal to 4. All right. Then don't forget that natural log is the same thing as log base e. So if I wanted to rewrite it, I would have to use that that e as my base. And this is just me rewriting it in exponential form. So it'd be e to the 4th power equal to that 2x. All right, divide by 2, x is equal to e to the 4th over 2. All right. Any questions? Any problems? And then once again, if my math lab wanted exact answer or if they want the decimal values, throw it in the calculator. This is your exact answer. But you put in calculator to find a decimal approximation. All right. Next one, we have log base 2 of x equal to log base 2 of x minus 7 equal to 3. So you see the method here. Option for us is to condense our logs, bring our logs together. Notice both of our bases are 2. So remember, if your bases are not the same, then you wouldn't be able to do this method. But since it is addition, that means I can bring together with multiplication. So that's log base 2 of x times x minus 7 equal to 3. All right, so we can rewrite it now in exponential form. My base is 2. So that'll be 2 to the third power equal to x times x minus 7. All right, questions, questions, questions. Now we just solved the quadratic equation. So you distribute x, that'll be 8 equal to negative, well, 8 equal to x squared minus 7x, before you do all this. 2 cubed, and then x squared minus 7x on the right side. Then you want to set one side equal to 0. And that'll bring us here. All right, solve the quadratic equation. That'll give you x equal to 8, x equal to negative 1. All right, so we do need to check them. Oh, let me go back. There we go. So we do need to check, and you check by plugging it into your original equation, taking 8. If you have a calculator, you can always feel free to do it that way. I went ahead and did it by hand, and so that's how you would do it here. And notice we get 3 equal to 3, so that checks out for us. Plugging in negative 1. Now, it's not about your solution being negative. It's about when you plug in the solution, will the law be applied to a negative value? So in other words, if I have log of x plus 8, when I plug in negative 1, that would be the log of 7. So that wouldn't be an issue. So it's all about what happens when you plug in the negative value. So in this case, it ended up not working for us. So you notice that we ended up having a log of negative 1. Then here, this would have been log of negative 8. You cannot take the log of a negative value. So that's why negative 1 does not work for us. So x equal to 8 works, but x equal to negative 1 does not. All right, questions? Any questions? Any problems? Everybody? All right, so let's look at the next method. One-to-one property for logs. Before we looked at one-to-one property for your bases, that for your exponents. So now we're looking at the one-to-one property for your logs. So we have log base b equal to m equal to log base b equal to n. I mean log base b of n. So now notice we have once again the same base for your logs. If you don't have the same base for your logs, then you're looking at a totally different situation. But if you have a single log equal to a single log, you can drop the logs and be left with just whatever they were applied to. All right. So here in this one, we have natural log of x plus 2 minus natural log of 4x plus 3 equal to natural log of 1 over x. So now we cannot apply what's going on here to this because first we have more than one log on either side of our equation. We need to have a single log on each side of the equation. So we're going to condense that left side and make that one single log. Since it's subtraction, that means I can bring it together by using division. So it's x plus 3 over 4x plus 3 that's being applied by the log on the left side. Right side I can leave alone. But I have natural log, one single natural log on both sides of my equation, so I can drop the logs. And that leaves me with just x plus 2 over 4x plus 3 equal to 1 over x. All right, questions. So now I'll solve it as if I would a regular problem. Cross multiply. That'll be x times x plus 2 on the left, 4x plus 3 times 1 on the right. Distribute. That'll be x squared plus 2x equal to 4x plus 3. All right, so we want to set one side equal to 0 because we have a quadratic equation. So I'm going to minus 4x and minus 3 from both sides. So that I will have x squared plus 2x, x squared minus 2x, excuse me, minus 3 equal to 0. All right, solve the quadratic equation. I ended up factoring, ended up giving me x equal to 3, x equal to negative 1 for my solutions. All right, one thing you got to plug them in to make sure. Once you do so, you'll see that 3 will work and the negative 1 will not work. So this will be our only, still have my eraser on.
I
Yeah,
have a
so this
question.
here just be my only solution. Yes.
Is the only time that we have to plug them back in to check when we're factoring?
Really, it's about when we had this scenario right here, when we have these multiple logs, because that didn't come up before then. when we start condensing our logs, yep, when we start bringing together these logs, you know how we did that here?
Yeah.
And so we ended up having multiple solutions. So we need to check. Really, is to be honest, if I tell you the math, you know, as a math teacher, I'm supposed to tell you to check all of your answers, to be honest. But yeah, most of the time the problem comes up when we start bringing our logs together and they
Okay.
start producing multiple solutions. So that's where I would lean towards when you would do it. Same
Okay.
thing happened here. Yep. Good question. Good question. All right. Anybody else? Anything else before I go somewhere else with our conversation? All right. Everybody good? Everybody good?
Professor Tucker,
Yes, sir.
I'm not good until I rewatch all your videos.
Man, ain't nobody talking to you. All right, so now just mess with you, man. Just mess with you.
I'm
So,
section 4. I'm like, Jesus. Because I'm like, I'm quiet. I'm like, ugh.
I believe you'll be all right, sir. I have confidence in you.
Thank you.
So let's look at where we're going with the rest of the class. So final exam week for us is that last week, that first week in May. That's our last week. We're in, I'll give you 2 hours to take the test. Your test is actually going to be on the 5th. And I'm going to send you guys an email with all this information. Our class normally starts at 12:30. So that's not going to change.
This is test 4 we're talking about, right?
Your final test, yes. Test. Well, I'm gonna go through all that. I'm gonna tell you everything about it. Give me a second. I'll just give you the details of when your final exam is going to be. So I'm gonna give you 2 hours. So, you know, class normally ends at what's supposed to be at 2. So I can give you to at 2:30. So that's May 5th. And so on May 3rd, though, you don't come to class because I'm giving the final exam that's going to bleed into your time. I have a 161 right in front of you guys, so I'm letting them take their test right before yours. So that's going to bleed into your time. So you don't come to class at all on the 3rd. You actually come on the 5th to take your final. Okay? So now you've had 3 tests up to this point. What I'm going to do is let chapter 4 be your final exam test. Since, if you notice what we did, especially in this section, it pulled from other sections that you had to go, that you talked about before, all the way back to chapter 1, you know, did linear equations, quadratic equations. So instead of me trying to take a test that's pulled from chapter 1, 2, 3, we'll just look at chapter 4 and that pulls from all of those other sections. So you have 3 tests that we've already been through, which is chapter 1, 2, and 3. And then this final test is actually going to be your final exam, which is chapter 4. And it will be on May 5th. So, and like in the previous class, they were like, so we don't have, you know, next time we're doing something is May 5th? Well, yeah, but that time will blow by quick if you're not careful. So looking at our calendar, next Monday, what is Monday coming up? Sorry. I have a funeral to attend, so we will not have class. So the next time I'll see you is next Wednesday. So, you know, I'm not coming with any new material. It's just answering whatever question you guys have. So technically, if you don't have any questions, I really don't need to see you again until May 5th, right? Once again, I'm going to send you an email with the details as to how we're supposed to handle your final exam and everything like that. And somebody also asked in my previous class, will there be a makeup like the last proctor test? Now, I am considering that, but it will be under the stipulation that you had to take the first test first, because it's really supposed to be your final exam. So I'm supposed to try to, you know, emphasize you guys taking the final exam. And then also the makeup score, highest score wouldn't be as high as 85, probably 75. Because like I said, I'm supposed to be pushing you guys to actually try to take this final exam, you know, like we would in a regular class setting. So, but I will do or set up all the details, give you all those details in an email. So these 3 classes, you're talking about the 21st, 26th, and the 28th are basically review days. I will come in, I won't have any new material. I will just say, what questions do you guys have for me? I will also have a review set up I think I already posted it for chapter 4s. So it's really going to be that same thing. I'll take a look and make sure. And so you'll be able to actually look at the review as well and see what type of questions you have coming into that class period. Oh, coming into the final exam, excuse me. Also, your My Math Lab work still will be due on 5/9. I'm not sure if I've changed it to 5/9 yet in My Math Lab, but it still should say 5/7 at least. Everything in My Math Lab will be due 5/9. All right.
I have a question.
Yep.
Okay, so you know how you always let us do the test reviews for extra points? Can we do test review 4 for extra points on the
Yep.
final exam? That's
Yeah,
my
I don't
phone. I'm
mind.
sorry.
That's fine. Yeah, I don't mind that happening. Yep. Score 85 or better, you get the extra points. Yep.
Okay, great.
Mhm. Anything else? Anybody else? Got to clear on the details.
So our final is on the 5th,
Mm-hmm.
and we have no class Monday. Then Wednesday, the next Monday and the Wednesday is review day. And then we have a final and then the class is over.
Yes, sir. That's it.
And all the homework and everything is due on the 7th.
The 9th. The 9th.
Nice.
It may, I was saying it may say the 7th right now. I just haven't adjusted it to the 9th. So
Okay.
that the 9th should be a Sunday.
Everything's due on the 7th.
And for the homework, it'll be for this chapter 4. Just finish off chapter 4.
Well, that's for those who are current. Yeah. For those who know they need to get caught up, it's everything from chapter 1 up to.
Oh, okay. So everything in general. Okay, perfect, perfect.
Mm-hmm. Yep.
Are we going to cover the last little sections, like the 8 and the 9?
Nah, we'll just leave it right here, chapter 4.
Okay, and we're just going to cover everything.
Mm-hmm. And so those other sections will. Where do you go there? I know chapter 5, Calc 2, Pre-Calc 2 starts in chapter 5. But anyway, there's an overlap, so you should be fine.
So
Okay.
we don't have to do those little sections, the ones he's talking about?
Nope. Unless you want some extra credit on your homework.
Okay.
If it were a test, then we're cooking.
Okay, so the test is on the 5th.
Mm-hmm.
But okay, cool. And so we're gonna take the rest of the time to work on this.
Yep. Get yourself ready for it.
And
Yep.
we'll see you next Wednesday for a review. Correct?
Right.
Oh, okay.
And these review days, if you have questions on back chapters, the floor is open. So you're not, you guys are not confined to just asking questions about chapter 4. If you have questions on chapter 3, I mean, feel free to ask them. It's your time.
And this test/final is only on chapter 4, none of the back stuff chapters,
Right.
just chapter 4.
Mm-hmm.
So section 4.1 to 4.4. Do you have an idea how many questions it is?
I forgot what I did, and I may, since it's a final, I'll have to take a look at it. No, but by next class though, I'll be able to answer that question.
Okay. 'Cause more
Can I
questions.
have you 2 seconds after class, Mr. Tucker?
Sure. All right. Anybody else?
I have a question.
Mm-hmm.
Are you gonna allow us to? Well, I'm gonna say it. I didn't do the reviews, the test reviews, like test review 1, 2, and 3, I guess.
Mhm.
Are they still open for extra credit, or they're not open?
Sure. Just now I know chapter 1 and 2, I think that due date is passed, so you have to shoot me an email to ask me to just remind me to go and open it up for you.
Okay.
Yeah. So
But
anything.
if you can open those up, I'll get those
Yeah.
done and get those extra points.
Yeah. So shoot me an email to remind me to do so.
Hey, I like extra points, Mr. Tucker. You know that.
Yeah.
I
know
always
that.
ask for that.
And so and then I'll shoot your email back to confirm that I did.
Hey, how about for another extra points on the test, we do I don't know what a class average, make a guess of class average between, if we go the entire class average is above 75, we get 7 points on the test on the final grade or whatever. And if it's below, nothing.
Let me think.
I mean,
about
something to think about.
I know you trying to find something, but let me think about it.
Yeah, class average above 75. That's a fair deal.
I'll think about it. I'll think about
Yeah,
it.
think about that. Come on, guys, bring up some ideas. We like extra credit here.
If you need help, bro.
Bro, hey, I like to keep my grades up.
Anybody else? Anybody else? Let me check. Extra credit for who talks the most in class.
Yay, come on. You were like bringing up an idea. I couldn't bring up anything else. I was like, let's do a class average.
That's a tuck out.
Yep,
Sorry for
yep.
your loss.
Oh, appreciate it, sir. Appreciate it. Thank you. Thank you. Thank you. Yep, yep. Anybody else? Anything else before we close today? Everybody good? All right. So, like I said, look for an email with the details as far as your final is concerned. But we got a little time before I have to send it out. But I'll try to get that to you before the week is out.
Hey, Professor Tuck, can you do me a favor?
Huh?
I know you got a full plate, probably. Can you upload the video as soon as possible?
Yes, sir. Yes, sir. I'm gonna try to get that to you. Well, shoot, if I can get it done today, I'll do it today.
I don't get it the first time when you lecture.
Mm-hmm.
Watch it several times over and over again for me to get it.
Yeah, it's all good. It's all good. I understand. All right. Anybody else before we close? Everybody good? All right. I hear people dropping out. So if you guys are good, I'm good. Have a great weekend. Be safe, and I'll see you Wednesday. See you guys on Wednesday.
All right, Professor.
Thank you.
All right. Thank you. You guys take care.